Okay, on section 1.2 starts on page 16 in the book, and would like to look at trigonometric functions, unit circle approach. Okay, two triangles we want to get out of the way. One of them is the 45, 45, 90, and the other is the 30, 60, 90. Trigonometry is based on those. Let's get this out of the way. If I'm talking about a right triangle with 90 degrees, if this is 45 degrees, this is automatically 45 degrees, which means whatever this side is, this side is. And if I use the Pythagorean theorem, say the hypotenuse squared is a squared plus a squared. Hypotenuse squared is twice a squared, and if I square root both sides, I'll get the hypotenuse to be the square root of 2, and square root of a squared is a. So this right here is the square root of 2a. And since I'm using a, not a number, this is a formula. That is, if I look at the sine of 45 degrees, and in case you're wondering, assume this is the angle I'm talking about. It's the opposite over the hypotenuse. It is the opposite over the hypotenuse. Those cancel out. I'm left with 1 over radical 2. And if you rationalize, that's radical 2 over 2. If I look at the cosine of 45 degrees, that would be the adjacent over the hypotenuse. And that turns out to be the same. And if I look for the tangent of 45 degrees, that would be the opposite over the adjacent, and there it is. Now, since I need to know this, 1/3 of the course is dependent on me figuring these values out. Since I need to know that, a quicker way of doing this, a more efficient way of doing this, is for you to use from geometry. I don't know if you recall these things. If you call this 45 degrees and this 45 degrees, if I divide by a all of these sides, you're allowed to do that in geometry. You could divide one side of a triangle by a value as long as it's divide all of them. If I divide everything by a, so I could say, look, if this is 1, this is automatically 1, and I could memorize easily that this is radical 2 times 1. And anytime throughout this course I need to find the sine of 45 degrees, I'll say, well, let's say that's 45 degrees, opposite over hypotenuse. The cosine of 45 degrees, adjacent over hypotenuse. You could rationalize and get those, of course. And tan of 45 degrees is opposite over adjacent. There it is. And I'm going to do the same. I'm not finishing this section today, but I'm doing the majority of it. If I look at 30, 60, 90, if I call this 30, and I call this 60. Now, if I label this side A, I'm stuck. Here, whatever this side is, this side is. Here, that's not going to work. So what I'm going to do, I'm going to draw an auxiliary figure. If you don't know what that means I'm going to add a piece to the graph. I'm going to reflect the graph, and I'm using a color that's hard to see. I'm going to reflect the graph with respect to this axis, making this 30 degrees, and this will copy right there 60 degrees, and whatever this is, this is. If I look at the new triangle, I do notice that, well, this side right here is 2a, but this is 60 degrees, this is 60 degrees, this is 60 degrees. That means this is an equilateral triangle. All the sides are equal. This is what I got. I started by calling this 30 degrees and calling this side A. I figured that the hypotenuse is twice that. And I could figure out what the third side is. If I call this side L, I could say L squared plus A squared equals 2A squared. So L squared would plus A squared equals 4A squared. L squared equal, if you subtract, 3A squared. And L will be, should be plus or minus, but in geometry length cannot be negative. So what did we conclude? This is radical 3A. And if I do the same, that is, if I look at the sine, cosine, and tangent, I could say the sine of 30 degrees is the opposite over the hypotenuse. That's 1/2. And the cosine of 30 degrees is the adjacent over the hypotenuse. Radical 3A over 2A, that would be radical 3 over 2. And the tangent of 30 degrees is the opposite over the adjacent. You could rationalize. Similarly, I could have done this. I could have said, well, look, divide everything by A. If you give me a triangle and you tell me what the side opposite of 30 degrees is, I'm going to call that 1. I memorize that the hypotenuse is 2, and the remaining side, the side opposite of 60 degrees, is radical 3. And can't I figure out all of those from this triangle? And I could figure out also the sine of 60 degrees is the opposite over the hypotenuse. The cosine of 60 degrees is the adjacent over the hypotenuse. And the tangent of 60 degrees is the opposite over the adjacent. And of course, I could figure out the remaining 6 trigonometric functions. Now, I just want to do 4 problems. If they say find the sine of 30, you could draw this triangle and say sine of 30. Well, the opposite over the hypotenuse, that's 1/2. Cosine of 45 degrees, this is 45 degrees. You could say, I'm going to pick this to be 45 degrees. That would be the adjacent over the hypotenuse. You could leave the answer like that on a test out of mind. You could simplify and say that is 1/2 minus radical 2 over 2. Or you could say that is 1 minus radical 2 over 2. This is a fine answer. If I look at 45 degrees, tan of 45 degrees, opposite over adjacent, and cosine of 30. There is 30 is the blue. Cosine is the adjacent over the hypotenuse. That will be radical 3 over 2. So that will be radical 3 over 2 as an answer. Secant for 30 degrees, there's 30 degrees. It's the hypotenuse over the adjacent. And cotan of 45 degrees, well, it's the adjacent over the opposite. That's a fine answer. You could rationalize if you like. For the homework, you should rationalize. And if in case you don't know, 45 degrees is pi over 4. If I take 45 degrees, multiply it by pi over 180, this divides this 4 times. So 45 degrees pi over 4. So this is nothing more than this angle. Sine is opposite over hypotenuse. Tangent is 1 over 1. So you could say this is 2 over radical 2 plus 3. On a test, this is fine. If I rationalize the denominator, that's radical 2 over 2 plus 3. The answer will be radical 2 plus 3. And out of this section, I want you to do that much of the homework for now. The rest of the homework will come in the next lecture.